Hey everyone, here is our next thing in notes, which deals with dilations. This is a type of transformation, but our size changes now. So it's a non-rigid transformation. So there's a spot here for vocab. I'm just going to go to what Big Ideas has. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point that we'll call C. All right. And that is called the center of dilation and a scale factor K. All right. So basically, we're dealing with scale factors here, which is a ratio of lengths of the corresponding size of the image and the pre-image. So it says a dilation with center of dilation C and a scale factor K maps every point from the pre-image to the image. So the following is true. If P is the center, then the pre-image and the image are the same. If it's not, then here is the rule. Here is how we find our dilation, our scale factor, okay? It is CP prime over CP, or you can think of it as the prime divided by the image divided by the pre-image, or a lot of times we call this scale factor, and the scale factor is typically your new image divided by the original image. That's typically what we have. All right. So yeah, there's scale factor and also written as dilation. Let's go to the next page. And then to do this with a graph, all the rule is the rule says, hey, if we have a point called X and Y, and we have a scale factor K, we literally multiply every coordinate by every X and Y value and every coordinate by the same number. Now, I do want to make one thing clear in this next part. We want to find the scale factor and then tell if it's a dilation sorry, if the dilation is a reduction or enlargement. What wasn't on the page before is an enlargement. Did I spell this right? An enlargement is where the absolute value of your K is greater than 1, and a reduction is where the absolute value of K is between 0 and 1. If it's exactly 0, then, well, it's no longer there. If it's exactly 1, the size hasn't changed. We want the absolute value. What happens is sometimes we'll give you a trick question saying, hey, K is -2. The negative just means, really, that we applied a 180-degree rotation to that image. But the 2 still means it is a enlargement because everything's twice as big. Anyways, let's go to these pictures. I want to remember the whole CP prime over CP. That is going to give me my K. So I'm going to look at K here. K equals C to P prime. Oh, it doesn't show that, does it? No, it shows from P prime to P is 2, and the whole thing's 4, so this is going to be 2, right? So this section is 2, and the whole thing's 4, this is 2, because I want C to P prime, so the image, that's worth 2, and then CP, which is C to the pre-image, is going to be 4. This is a K that is 1/2 or 0.5, known as a reduction. Now over to 2, the whole thing's 25 CP prime, so I know from C all the way to P prime is 25. So K equals 25 divided by C to P is 20. So 25 divided by 20 is 5/4 or 1.2, which means this is an enlargement. And then for number 3, C to P prime is 27. C to P is 9. So K equals 3, which is also an enlargement. All right, let's go to example 4. So example 4 and 5, this is where we're going to graph the original image. So let's go to -3, 1, -4, -1. So here's my A, here's my B. Actually, I'm going to write A somewhere else just so it's not in the way. And then C is -2, -1. There is C. And here is my triangle that I have. Now we want to multiply this everything by 2. So that means we want 2x and 2y. So I'm going to write down underneath here, what are those values? So a prime, multiply everything by 2, I get negative 6, 2. B prime, I get negative 8, negative 2. And then C prime, I'm going to get negative 4, negative 2. So now we're going to graph that. So negative 6, 2, there's A prime. Negative 8, negative 2 would be B prime. And then negative 4, negative 2, this would be C prime. And so this is our enlargement. All right, next page. We're going to do the same thing, but now we have a reduction that's going on. So let me zoom in a little bit. Let's go ahead and graph these. Negative 10, 0, that's P. Negative 5, 0, that's Q. Then we have 0, 5, that is R. And then negative 5, 5, that is S. And this looks like a nice parallelogram here. Now we want to multiply everything by 1/5. So P prime is going to be negative 2, 0. Q prime would be negative 1, 0. R prime would be 0, 1. Then S prime would be negative 1, 1. So let's go ahead and graph these. Negative 2, 0, that's P prime. Negative 1, 0 is going to be Q prime. 0, 1 is R prime, and negative 1, 1 is S prime. And then there we go. There is our new parallelogram. Yeah, with that reduction. All right, we're going to skip the next two. Let's look at 8. Poster, 8.5 by 11. And then another one is printed by 34 by 44. What is the scale factor? So remember, scale factor we talked about is your new divided by the original. So our new one here, let's just look by one dimension. I like the 11 and the 44 because they're easy to use. So our new one's going to be 44. Our original one's 11, which is going to be a scale factor of 4. So 4 times bigger. Number 9 shows an image that's 10 times the actual size. The image is 8 centimeters long. What's the actual length? So we have the new image, which is the book, okay, divided by the original. This is how we need to think of this. All right. Now it says the book shows the image is 10 times the actual size. So this needs to be a scale factor of 10. So how do we do that? What happens is now what we can do, it says the image that we see is really 8. So we can put the 8 here. So what we don't know is we need to now erase this bottom part here. And this is where X is going to be. So what is the actual this thing that we have here? So we cross multiply, we're going to get 8 equals 10x. If we divide both sides by 10, we get x equals 0.8. So 0.8 centimeters is what we would get here for the actual size of the insect. All right, there's your notes. If you have questions, reach out. Have a great day.